Alright, so in this section, we're going to talk about the addition rule. So we're just going to elaborate on our basic probability sections what we did last week. So what we're going to do is we're going to talk about the probability of the or probability. So meaning if we want the probability of one event happening or the other event happening. So one or the other happening when it comes to it. The most easiest one that comes to the ors is counting cards or betting is the biggest stuff when it comes to or the easiest examples when it comes to the or probability. But for this one, we have to talk about define a couple of things. Okay, so the first thing we have to define is something called the disjoint events. Okay, so disjoint events is events A and B are called disjoint events or mutually exclusive. That's another word for saying it. Is if they cannot occur at the same time. Okay, so what I mean by cannot occur at the same time is it doesn't go one or the other. So I'll give you an example of what it means by it doesn't overlap. The easiest way I can think of it, like in an algebra function, is two circles do not overlap. So that's when it doesn't happen at the same time. So if you notice A and B literally have nothing in common or no overlap, that's what you mean by disjoint events. Okay. Another concrete example is the one at the very bottom here. Let's suppose we have the example S equal the sample space equal the numbers 1 through 7. And 11, let's say event A is the numbers 1, 3, and 4. And event B are the numbers 5, 2, and 7. Okay? So the question is, are these two events disjoint? Meaning, do they have anything in common? And no, right? They do not have anything in common, so the events are yes, right? They are disjoint because, again, they have nothing in common. So there's no overlap between one and the other. And so that's what he means by events are being disjoint. Okay? So when it comes to the OR probability, it has its own exact equation. So given two or more events, A and B, the probability of event A or event B occurring is, and it's equal to this equation here. So this is our OR probability equation. So the probability of A or B happening is equal to the sum of the individual probabilities put together. So notice, right, this is the probability of A plus the probability of B. So it's the sum of the individual probabilities put together, again, if the events are disjoint. Okay. Now here's the very big thing about this type of scenario is it doesn't always have to be two events. It's two or more events, which you'll see in a couple minutes of an example based off that information. But again, it doesn't always have to be on just two events. We'll talk about that in a little bit. Okay. So here's another example illustrating this out. So suppose we toss an 8-sided dice. What is the probability of getting an even number or a 7? So there we go, right? Key term or. So that means it's going to be here. Now, here's the problem. We had to identify if the events are disjoint. So our sample space are the numbers 1 through 8. Okay. Let A be its event even number. So I'm going to write all the even numbers between, the sample space. And event B is getting a 7. Well, it's just a 7, right? That portion. So the question is, are the events disjoint? Meaning, do they have any overlap? And yes, right, they're disjoint because there's no 7 or vice versa. So, right, there's no overlap. So yes, they are disjoint from one another. So therefore, the answer is probability of A plus the probability of B, right? So what's the probability of A happening? So, well, what's the probability of A? So a total of 1, 2, 3, 4 times this happened out of a total of 8, right? Just basic probability. Plus, now over here, what's the probability of B happening? So what's the probability of getting a 7? Well, there's only one way out of a total of 8 different ways. So adding them up because that's what our equation tells us to do. So our answer is 5 out of 8. Hence why it's called the addition rule for this section, because we're actually adding the probabilities together. Now here's the key thing when it comes to the addition rule. These two numbers at the bottom will always be the same. They will never change. Okay, which means if you somehow adding stuff when it comes to it, and this is like 1/4 and 1/5, you're automatically wrong. These will always be the same because we're doing the same exact portion. It's one or the other in a simple event itself. Okay, which means you're either be adding the tops itself. Okay, not the bottoms, right? They're just adding fractions, right? That makes sense, right? Everybody knows that when it comes to adding fractions, you never add the bottom numbers, right? Okay, so now let's try an actual pretty interesting question. So if you don't know no deck of cards, you can just Google them. It's pretty straightforward when it comes to deck of cards portions. I'm just going to go with, the basics, right? There are a total of 4 suits. There are hearts, diamonds, clubs, and spades. So it's a really bad spade, but you guys get the picture, right? And each one has a total of 13 each in its individual one. And it goes through aces, so 2 through 10, and then jacks, queens, kings, and an ace, right, when it comes to it. But, again, if you're not sure, you can always Google it, or you can use the paper of the deck of cards I have on there as well. Okay, so using that portion, so given a deck of cards, find the probability of getting an ace or a king. All right, so an or. All right, so that's what we're going to deal with. So ace. So my probability of A is just an ace, and event B is a king. Okay, so are there two events disjoint? So in other words, can I get an ace and a king at the same time? Hopefully saying no, right? So that means these are disjoint events, which means we're going to be using this probability. Okay, so the probability of A or B is equal to the probability of getting an ace. Well, how many aces are in the deck? 4, at a total of 52 cards in the deck, not including jokers. So plus, okay, what's the probability of B? So what's the probability of getting a king? Well, there's 4 of them, again, at a total of 52. So we add them, so our answer is 8 over 52. Right, for probability of ace or a king. Okay. All right, so let's keep going. So B says, what's the probability of getting an 8 or a 4 of hearts? All right, so event A is just getting an 8, and event B is getting a 4 of hearts. Okay. So again, what's the probability of A or B? So it's just adding each one. So what's the probability of getting an 8? Well, how many 8s are in the deck? So again, 4 out of 52. And how many 4 hearts are there? Well, there's only one 4 of hearts out of 52, right? So again, it's not just a 4, it's 4 of hearts. So it's more particular, so right, when it comes to it. Okay. And then we just add them up, so this is 5 out of 52. All right, so for C, kind of messed up. It's supposed to be queen of spades. Oh, I spelled it right this time. It's queen of spades. That's nice. So what's the probability of getting a queen of spades or an ace of diamonds? So why don't you guys try C real quick. So I'll give you a quick pause. 3, 2, 1, pause. Try it out. Okay, so what's the probability of getting a queen of spades or an ace of diamonds? So A is queen of spades, B is ace of diamonds, right? So the probability of A or B. So what's the probability of getting a queen of spades? Well, there's only one queen of spades, right? Came to it. Plus ace of diamonds, so there's only one ace of diamonds. So our answer here is 2 out of 52. Okay. All right, so let's do a couple more examples to get you accustomed to using the OR rule, okay? Question 2. So using a deck of cards, find the probability of getting a red card or a black card or an 8. So now we have 3, right? We have 1, 2, 3, because it's OR and an OR. So event A is a red card. Event B is a black card. And event C is a 8. Okay, so we can just add A or B or C, because that's what we want now. So it's going to be the addition of each individual one. So what's the probability of getting a red card? Well, there's a total of 26 red cards, right? So I don't care if it's, heart or diamonds, it's just a red card. Plus, how many black? Well, again, there's also 26 black. And then how many 8s? We did that earlier. There's 4, right, when it came to it. So adding all these up should give us what? 56, I believe. 56 over 52. Okay. So, I have a question for you guys. Does that make sense? Because when you divide it, 56 over 52, you actually get 1 point something, which is bigger than 1. So if you remember your basic probability concept, a probability must be bounded between 0 and 1, not higher, right? So anything higher than 1 is guaranteed to be wrong automatically. Well, that would be a problem. So it doesn't make sense because it's more than 1. Now here's a question for you guys. Are the events disjoint? For example, can you get a red and a black card? No, that's good. But can you get a red card that's also an 8? Yes, right? You can. Can you get a black card that's also an 8? Also yes, right? So that means they're not disjoint, they have overlap to each other. So the question now becomes, what do we do when we actually have overlap to one another? So overlap will look something like this, right? So when they have stuff in the middle, they both have in common.